So we've got kind of quite a list of things to do today. And I do want to let you know a couple of things. First of all, please stop talking. I know that there are a number of people that are planning to come in to do corrections. That's awesome. I kind of expect that we'll have a big group of AP Physics people working on corrections, which honestly, you guys, I know that when you got the test back yesterday, some of you were like, what? But it's learning process, right? I'm writing questions that are what you're going to see on an AP exam, because that's my job, is to get you ready. We're going to get you through it, okay? I would not expect that all of you get an A+ on an AP Physics test, okay? If you did, then you probably shouldn't still be in this class. Do you know what I'm saying? Because probably then you are above and beyond where we need to be. So learning is good. One of my regular physics students last period, they just took a quiz over some stuff that's kind of hard. It's not stuff we've done yet. We're going to do it in a couple of weeks. And she said, you know, I had in my head that I couldn't do it, and then I didn't think I could. But yesterday when we worked, I got it in my head that I could do it, and I felt great on this quiz. You know what I'm saying? So I just want you to get that mentality back. Even if a test doesn't go well, that does not mean that you can't do stuff. You absolutely can. You guys are great, and you're smart, and you'll get there. Okay? And on some of these problems, it's just a matter of flipping one little thing in your mind, and it gets where it needs to go. That's what we're doing. So if you would like to come in during Liberty Time, I'll write you a pass very happily. Today or tomorrow is perfect. And I'd love to see you. If those times don't work, I'm here 7th as well, 3rd, before school, after school, kind of, and we'll talk about the rest of the week in just a second. Question? Not right this moment. If you were not here yesterday, then you can see your test at the very end of class. During 7th period, you can come in during Liberty Time. Any of those times are perfectly fine, but not right this moment, because we're going to do this stuff right now. So we're going to go over the graphing sheet that we started yesterday. That hopefully you finished. We're going to go over some homework. Hopefully that all kind of went well. And we're going to build on that today. We're going to do some free fall information. You do have some homework, and many of you are going to be thrilled. I'll get you papers in just a sec. I haven't forgot. You're going to be thrilled to know that I even have updated the calendar on Canvas, right? I did. I really did. Oops, this isn't your class though. Hold on just a second. AP Physics, that's what we want. And I wanted to draw your attention to this just so that you're aware, not only because I'm just like, yay, look at me, I did it, because, you know, sometimes that's a big deal for me, but also just to make you aware of what we are doing. So today is Tuesday. I'm going to introduce free fall to you. We've talked a lot about it without articulating exactly what it is. So today is the day we're going to do that. Tomorrow we're going to take some data for a lab. We're going to do the data collection part of a lab. Thursday and Friday afternoons, I will not be here. Thursday, I'm going to a training, and Friday, I am actually going up to Carleton to listen to, I don't know if you guys have ever heard of Mae Jemison. She was the first African-American astronaut. She's speaking up at Carleton, and I'm going to go see her, and I'm super excited. And I'll take pictures, and I'll show you and all of that sort of thing. But anyway, she's going to be there, so I'm going to go see her. Also, one of my professors is retiring, so we're like having a big whoop-de-doo for him. Anyway, so that's where I'm going to be on Friday. So we're kind of at the point where we're getting close to a test. I figured, though, you probably wouldn't be thrilled with taking a test without me here, or taking a test the day after I'm gone. So Kate says, what? And I recognize that even before you said it. So we're going to take data on Wednesday. You've got some things to do Thursday and Friday, and I will provide videos to help you get all that stuff done. So even though the sub may or may not know physics, you will still be doing physics Thursday and Friday. Does that make sense? Okay, it's all stuff that I know you can do without me standing here talking to you. Monday, we'll pick up any pieces that we need to pick up, tie up any bows that need to be tied up, and then Tuesday of next week, we will test over this material. Question?
I know yesterday you said you go over AP grading. How are we going to do that?
Yep, it's on my list. Okay. Yep, it's actually the first thing after this. Yep. Yep.
Okay.
I got you. I just didn't put it up at the very top. Yep. Other logistical questions? Okay, so let me answer that question, Tate. So your question was about AP grading. So some of you have asked me throughout the year so far, and I talked to Mrs. Bream. I didn't have control over it. She had to do it for me, the registrar, because she has master control over Power School. So I talked to her, And I have not done anything with Power School since then, so I haven't even looked at your grades or how they've been adjusted or anything like that. But this is the AP grading scale that I was told is being used. So it's actually just that first set there, okay? So don't ignore this stuff. But that's where we will be, okay? So an A minus is going to go down to 86, I think. No, 85, I guess. Is that right? B plus is going to go or B is going to go down to like 70. Does that make sense? So it's adjusted a little bit to acknowledge the fact that this is a hard class. I'm all for that. But ladies and gentlemen, I'm going to tell you that I know some of you are driven by letters that appear on your transcript. I am not driven by that. And I want you to start to break out of that. And I know it's hard because you've been indoctrinated about that since you were 3 years old. I know you have been. I totally get it. And I have too. But I want you to start thinking about it in terms of, am I learning and am I mastering stuff? That's what I really want you to focus on. That's what's going to get you the grade that you earn and deserve. Okay? Question?
They should just change district policy if they want to encourage this. Because the GPA system is designed.
No, I know. And mentality is changing, but it changes slowly.
But the way they design the GPA system doesn't encourage you to take hard classes.
I get it. Sweetheart, I have lived and understand that concern so much. So, it is what it is. We can have that philosophical discussion anytime you'd like, and I love that conversation, but that's not what's going to be on your test on Tuesday of next week. So let's do that stuff now. Does that sound cool? Yeah. All right. So, yep, I'm going to do that right now. So we're going to go over, we're going to go over the green graphing sheets, okay? So pull that out, and you can also pull out your homework because we're going to do that as well. Got 1, 2, how many people did I have missing yesterday? Let's see what I got left. Is there anybody else? Everybody else got it? All right, pull it out. All right. This is like a really bad copy, but it's going to be what it's got to be. So, ladies and gentlemen, if the transition between one thing and another takes an extra 2 minutes every time, we will not get to where we need to be. Okay? I need you to be responsible kids. I need you to be responsible young adults and work with me here. Okay? For those of you that weren't here yesterday, we did record what we did yesterday. You can find it up on YouTube. But right now we're just going to kind of walk through things. I'm just going to go through this, asking for answers. If there are questions or concerns, then absolutely we'll talk it through. Okay? This is based on the content that we talked about before or talked about yesterday. We noticed, and I hope that you did, because if you don't, it's really hard to answer these questions, that this is a velocity versus time graph. All right, so we're just going to go table by table. We're going to start back with the back table with Ellie and Grace and company. Is the acceleration between 2 and 3 seconds or between 5 and 6 seconds greater? What'd you guys say? 5 and 6. And I'm going to ask that question, that eternal question that I do. Why? Or how do you know?
Because the slope is steeper.
The slope is steeper. So between 2 and 3 seconds, we're looking at a slope like this. Between 5 and 6 seconds, we're looking at a slope like this. Does that make sense? A friendly reminder for those of you that need it, that the slope of a V versus T graph tells you the acceleration. Awesome. All right, question B, question part 2. During what time interval is the acceleration 0? Looking at Aiden's table, what you got?
3 to 5.
3 to 5?
Yeah.
And how do you know that?
It's flat.
Because it's flat. Tell me a little bit more technically what you mean by that, Rudy.
The velocity doesn't change.
Velocity doesn't change. No change in velocity. No acceleration, since acceleration is change in velocity. Right? Again, the slope of the V versus T graph tells you the acceleration. All right, we're going to go back to Nick's table. What is the displacement between 5 and 6 seconds? 5 meters? Do we agree? How do we figure that out? Make a triangle? Is that what you're going to say? Or were you going to say something else, Henry?
It's just simple, 'cause it's count over.
Just simple. What do you mean you just count over? I don't know what that means.
Well, there's in between 5 and 6, it's 1 second, and then you count the number of blocks over, like the top to. I know what I'm doing. I just don't know how to explain.
Okay. Well, and what I want to do as a physicist and as a physics teacher is to get you to explain. Mia looks like she wants to talk, though, too. So go.
Well, the velocity at 5 seconds is 10, and the velocity at 6 seconds is 15. So that's 5 meters per second times 1, which distance is
5 meters per second times 1 second. Is that what you're saying? Okay. Do you guys agree? Does that match with what you said? I understand what you're doing, right? So you're saying you go 5 meters per second change in 1 second. So I'm cool with that. And that also, if you look at the units, is going to cancel your seconds out, so you've just got meters. So I'm cool with that. Jasmine, you look a little bit unhappy with that. Or maybe not unhappy. That's kind of a harsh way to say it. But maybe you don't agree?
Well,
Do you want to talk? Do you want to say some more?
yeah, I used what you told us yesterday, saying that going from the left direction, you have to draw like a triangle or a rectangle and then find the area of that to figure out distance.
Okay.
So I drew that triangle there. The height was 5 meters per second, and then the base was 1. And so 5 times 1 divided by 2.
So you're finding the area of this triangle? What do you guys think? And so what did you get then if you did the area of that triangle?
I got 2.5 meters.
You got 2.5 meters? So that's another possible answer. Nick's waving his hand kind of in the air.
Well, I just kind of, at first I got 2.5 seconds, but then it didn't really make sense to me because if the velocity, it starts at 10, it goes up to 15, like even if it stayed at 10 throughout that whole second, but wouldn't it be at least 10 meters that it traveled? But since it's increasing, it's going to be even more than that. And so I said it was going to be 12.5 meters. Wasn't sure if that's quite right, but that's made no sense to me.
So where did you get the 12 and a half from?
I did kind of a different method.
It's okay, keep talking.
For the height, I added 10 and 15.
Okay,
I kind of got the average of those two.
okay,
Added them up, divided by 2, then multiplied it by the base,
okay.
which was 1, so 12.5. But it didn't really make sense to divide by 2.
Okay, so really what you were doing is that proof in geometry that as a geometry student, you never know why you do it, okay? When you're finding the area of quadrilaterals in geometry, I used to be a geometry teacher also. When you're finding the area of things in geometry, you have to like prove why things happen, right? Really what you were doing is finding the area under the curve, the total area of this thing. What is that shape? It's a trapezoid. So really, without knowing it, Nick, what you did was to derive the formula for the area of a trapezoid. So good for you. Okay? So if you remember back to the fondness of geometry class, you would say that you do the base 1 plus base 2 divided by 2 times the height. Okay? Or if you're like, I don't remember that because I haven't done geometry in a while, you can also make an argument that, well, that's 1 times 10, so that's just 10, right? 10 for that blue rectangle and 2.5 for the purple triangle, and you can just add those up. Yeah, yeah. But do you understand, let me ask this question real quick, Jasmine, and then I'll answer, and then I'll address what you're saying. Do you understand the thought process that Nick went through? Because you articulated that really, really well, and that thought process is like the quintessentially what you need to think about, right? He said, I got 2.5, but if it starts out at 10 meters per second and it just travels for a second at 10 meters per second, it's going to go way more than just 2.5 meters. right? Like yeah, it has to be more. So it's gotta be the entire area under the curve. If we had looked at just, 1 second and it goes up 5 like that, then it absolutely would have only gone 2.5 meters. But because we started going pretty fast anyway, it's gotta be even more. Yeah. Go ahead.
Oh yeah, I mean that makes sense. I just didn't understand what it was asking.
Yep, that's okay. Yeah. This is learning, right? Learning happens. Yay, learning. So the moral of the story is the ones that we did yesterday when we did area were simple. They were a simple rectangle or a simple triangle, and now we're doing something a little more complicated, right? So the moral of the story, and we might want to write this down in your notes, maybe where you were doing it yesterday or on this sheet, depending on where you're going to look when you're processing all of this stuff, okay? Is that when you have a velocity versus time graph, to find the displacement, you calculate or determine, or whatever verb you want there, the area between the graph and the axis. Okay? So it's the entire area between the graph and the axis. Would you gentlemen put your water bottles away? They're getting really distracting to me. Thank you. Okay? Does that make sense? Bless you. Learning happened? Yay. All right. So the actual answer that we really want here is 12.5 meters. Cool. All right. So the displacement between 5 and 6 seconds was 12.5 meters. What was the acceleration between 5 and 6 seconds? Where are we at? We're going to come over here to Isaac and Tate and Henry. What did you guys say?
1.
1, he says. Why did you get 1? Where'd you get 1 from?
Slope.
So we're looking at the slope of the graph. And so we're doing rise over run. What is the rise? How high does it go? Does it go 1? This starts at 10 and this goes to 15. So what's the change in y? 5. What's the change in x? 1. So what should the slope be, friends? 5. 5 what? Meters per second squared. Do the units make sense there? It's meters per second, which is meters per second squared. All right, so make sure that if you get something wrong that you're writing this down, right? We're learning from this. It's the beauty of physics, the beauty of science, the beauty of learning. What is the displacement between 3 and 4 seconds? Where are we at? We are down here. What did your table get? Or do you have a sense?
10 meters.
You got 10 meters. And how did you get 10 meters?
Because from 3 to 4 seconds, the velocity is constant, and it's 10 meters per second, and the time period is 1 second.
Awesome. So this is kind of part of the discussion that we had with question C, right? Maybe I should flip question C and question E. But anyway, it's the area under the curve or between the curve and the axis. 10 times 1, 10 meters. How are we doing? So far, so good? Okay. I'm going to have you flip over to question 2. I'm going to give you 1 minute with your table mates to converse about question number 2, to answer the questions if you don't have them. Go, 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 so fast. 1 minute.
Yeah, I did that one weird too. Because it's not on it. It's a bad graph.
Yeah, it's not. The ones
Criticizing my graph?
Okay, you can't. It's not zero. It looks like there's a point that there's not.
Well, there's not a what? I'm just curious.
At 15, it looks like it's at 51, but it's not.
Oh,
Because it's really pixelated.
that is
So
9 meters.
your velocity could be off on C. Like, I use that as a
You guys
point.
voted 2
It
for 5,
wasn't
that's not
point, so
bad.
it was
3 for 5. 3 for 3.
3 for 5.
You said 3 for 3.
All right, I think it's been a minute or so. I'm looking at Kian's table. Question 1. Oh, and we noticed, ladies and gentlemen, that we don't have a velocity versus time graph this time, right? Got to pay attention. So this one is a position versus time graph, just making sure you're paying attention every time you look. All right. What is the velocity between 20 and 25 seconds? What'd you guys say?
0 meters per second.
Why did you say 0?
Because it's not changing in position.
Okay. So it's not changing in position? The technical way to say that would be that the slope is also equal to 0, right? But I totally agree with that. Absolutely. It is not changing position. It's not going anywhere, so it's not moving. All right. Part B says, is the velocity greater between 0 and 5 seconds or 10 and 12 seconds? Gunnar, what did your table say?
We said 10 to 12 seconds.
10 to 12 seconds, they said. And why did you say 10 to 12 seconds?
Because the slope at 10 to 12 seconds is greater than 0 and 5 seconds.
Awesome. So the slope here goes like something like this. The slope at 10 to 12, oops. Yep, 10 to 12 is something like this. Whoa, come on, team. So it's a little steeper. A little steeper means a little faster. Awesome. All right, we're going to come back for part C to Kate's table. What is the velocity between 15 and 20 seconds?
9 over 5. What did I say? Kate's table.
We said
I said Kate, sorry. Fair issue, yes. 9/5. Mm-hmm. Yeah, or 1.8. Yep, nice job. That's what I said too. 9/5-ish. During what time interval does the object accelerate?
Wait.
Oh, what?
This is what we were talking about on C. It's
Yeah.
not 9:05.
It's-
It's not an actual point.
You know what? For all intents and purposes, for our deal, we're going to call it 9/5. Okay? Approximately 9/5. Little wavy line. Whatever. I'm calling it 9/5. All right. Abhishek, I'm going to come back to your table. D. During what time interval does the object accelerate? What'd you guys say? 0 to 12 seconds? Do we agree?
I had 0 to 20.
0 to 20 seconds.
Oh, no. He's right.
Why not?
Because it's curved. It's not straight.
Yes.
I saw this last night. It's a epiphany.
Awesome. Learning is happening. I love it. Curved position versus time graph means that you've got acceleration. That would be another, like, one of those key things you may want to write down. If you have a curved position versus time graph, that means that your velocity is changing. If your velocity is changing, you're accelerating. Okay? Change in slope, change in velocity, acceleration. Okay? Some people on this sometimes argue that, like, from 0 to 4 or something is kind of straight. So, again, we're learning through doing. That's our goal. All right. Part E says, what is the displacement between 15 and 20 seconds? And we'll go to this table right in the middle.
9M.
9 meters?
9 miles.
I'm going to go with meters. How did you get 9 meters?
It's 9.
Blah, 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 blah. How did you get 9, Henry?
Like, it's counted the number of cubes.
Yes. High five for that.
Yeah.
Sometimes, and ladies and gentlemen, the reason I asked him and the reason I wanted to push it is because sometimes when you're doing these graphs and when you're looking at DV and A graphs, you're like, I gotta find the slope or I gotta find the area. And this one is literally just counting, right? This is like the graph skill that you learn in middle school or in elementary. You just gotta know what to do for each case, okay? So know that sometimes you're just gonna count. Sometimes you're gonna find a slope, sometimes you're gonna find an area. Questions on this before we move on? All right, let's keep cruising. Questions on the homework from yesterday? 3, 4, and 8. Anything you want to go over on there?
Hold on.
Okay.
This is career volume and acceleration.
3, 4, and 8.
Stops at 12. Career volume acceleration. Goes from 0 to stops at 12. Accelerate from 0 to 12 seconds.
Number 4, we can do it.
Next spot, wait, spot, 20.